What's the one thing that keeps pretty much every cloud architect up at night? It's a massive region-wide outage. Well, today, we're going to dive into how major applications can actually survive these kinds of disasters. We'll look at how you can build an automated safety net for your cloud apps using Azure Traffic Manager so they stay online no matter what.
All right, let's just jump right in and talk about the core problem, the absolute nightmare scenario that this whole technology was designed to prevent.
And it all boils down to this one really high-stakes question. What happens when your primary Azure region, the place that's serving all your users, just goes down? The answer to that can literally make or break a business.
Because look, the consequences are direct and they're painful. You've got frustrated users, a damaged reputation, and of course, lost revenue. The whole goal here is to either eliminate downtime completely or, at the very least, crush that recovery time from hours down to mere seconds.
So how do we solve such a massive problem? Well, let's introduce the hero of today's story, a very clever, completely automated DNS traffic cop. And that is Azure Traffic Manager. Now, the phrase you really want to focus on here is DNS-based. See, unlike a traditional load balancer that's stuck in one data center, Traffic Manager works at the DNS level, which is basically the internet's global address book. And that's what makes it so resilient. It's not tied to any single location that could fail. So how does it work its magic? Well, it's constantly juggling a few key tasks. First, it's a traffic director, sending your users to the right place based on rules that you set up. But, and this is crucial for disaster recovery, it's also a health monitor. It's constantly checking your application's pulse. The second it detects a problem, boom, it automatically reroutes traffic. That's how it ensures high availability and triggers that seamless automatic failover. Okay, so let's walk through what a real-world failover looks like. What actually happens second by second when an outage hits. All right, picture this. It's a normal day, everything's running smoothly. Traffic Manager is directing all your users to your primary region, just like it should. And meanwhile, your secondary, or failover region, is ready and waiting in the wings. But it's totally passive. It's just on standby. And then, disaster strikes. Your primary region has some kind of service disruption. Those health probes from Traffic Manager that are constantly checking in, they suddenly fail to get a healthy response. So Traffic Manager immediately marks that primary endpoint status as degraded. And here's where the magic really happens. The moment the primary is marked as degraded, Traffic Manager automatically updates its DNS records. All new requests from users are now seamlessly, instantly routed to the healthy secondary region, which flips from standby to active. And the most important part? This all happens with absolutely zero manual intervention. Nobody has to wake up at 3 a.m. to flip a switch.
Okay, so you might be thinking, wow, that sounds incredibly powerful, but it must be a nightmare to set up, right? Well, what's really interesting is just how straightforward it is to configure this safety net for your own applications.
It really just boils down to three main steps. First, you create a Traffic Manager profile and you pick the priority routing method. This just tells it to always send traffic to the healthiest endpoint with the highest priority. Second, you define your endpoints, marking your main site as priority 1 and your failover site as priority 2. And finally, you set up the health probes. You tell Traffic Manager exactly how to check if your app is alive and well.
Now for the part that really matters, the payoff. How quickly can the system actually recover from a total disaster? We're not talking about hours or even minutes here. We are literally talking about seconds.
So the speed of this failover really just comes down to three key settings that you control. First is the DNS TTL, or time to live. This is super important. It tells web browsers and servers how long to remember an IP address before asking for a fresh one. A lower TTL means a faster switch. Next is the probing interval, which is basically how often Traffic Manager is asking your app, hey, you okay? And finally, the retry count, which is how many failures it'll tolerate before it declares an actual outage.
And believe it or not, those three variables plug right into the simple formula you see right here. This is how you can precisely calculate, and more importantly, control the maximum time it's going to take for your failover to complete. It makes the whole disaster recovery process completely predictable. So let's plug in some common numbers from Microsoft's own documentation. If you set the DNS TTL to 10 seconds, the probing interval to 10 seconds, and the retry count to 3, your maximum failover time is just 40 seconds. I mean, think about that. Your entire global traffic can be rerouted and your application back online for your users in under a minute. Now, you might be asking, well, why have a retry count at all? Why not just fail over on the very first error?
This quote from the source material explains it perfectly. By setting that retry count to something like 3, you prevent a failover from happening just because of some tiny temporary network blip. It adds a really crucial layer of stability to the whole system.
And that really brings us to the bottom line, doesn't it? When you can recover from a complete regional disaster in about 40 seconds, the game just completely changes. So the question I want to leave you with is this. How much would 40 seconds of downtime cost your business compared to the hours, or maybe even the days, of a manual recovery?